Hey guys, we're back. So I'm going to talk about the notebook part now. And since this is the first notebook we've done, I'll talk about the notebook in general, and then I'll talk about specifically what needs to be in the notebook for this experiment. So having said that, I'm going to go ahead and pull up some information that we need to be able to do this. Sorry, trying to make sure I'm in the right place. I hate it when I do this. Okay, let me share my screen. And I am currently in the shell. I'm looking at the content. This is under course documents, and this is the notebook format. Okay, there are some things in here about how a notebook needs to be kept for it to be an appropriate notebook. Now, please understand that a lab notebook is a legal document. So there are some rules and precedents about how you're supposed to keep that document. Part of my job is to teach you about those rules and precedents. Now, I understand that you may not be working in a lab ever in the rest of your life, but it would be wrong for me to let you do things in the laboratory or keep your notebook in such a way that it would not be acceptable if you were. Okay. I used to work in industry. My lab notebook was used by not just me, but also other people that I worked for. And they had to review it in court cases. So there are certain things that had to be done in certain ways. You are expected to have a table of contents. It is expected that it will be a bound notebook, not spiral bound, but bound. That way, if a piece of paper is taken out of it, it's very obvious that it has been removed. The pages should be numbered. And since the composition books that most of you will be using don't have numbered pages, you are responsible for numbering them. Now, I realize that can be changed. I don't really like that. Really, we're not allowed to do that in industry. They have to be pre-numbered because then we will know if another page has been removed. Okay. Your experiment for each one, I want to see the experiment number and the title, the objective in your own words, a list of all materials, whatever you need so that you can collect that stuff. I mean, if you were in a lab, so you could collect all that stuff without having to flip through a bunch of papers. There need to be data tables, and we'll talk about what those need to look like in just a second. And then anything that the pre-lab asks you to calculate needs to be in there. Now, your data tables will get filled in the laboratory. Beyond that, nothing else is required in your lab notebook. Absolutely nothing. There are some additional conventions that go with that. So if you make a mistake in your lab notebook, I want to see one line through it, initial and date. Okay, anything else is a problem. And why is that a problem? Well, okay, let me ask you this. How many times have you done something, assumed you made a mistake, X'd the heck out of it, and then gone, oh, wait, I actually needed that? It happens a lot. And that's why we don't do this. That's why that thing should still be readable, even though you crossed it out, just in case crossing it out was actually a mistake. So that's why we do that. And we have to acknowledge that we did it and what day we did it. Okay. The date part is all about who did what first. So we need to have documentation of when these things were done in case two people had the same idea and they have the same data, and then we have to see who actually had the idea first because they're the ones who get credit for it. Okay, so that's what that all comes about from. All right. Now, it says, or the example that I've provided to you has a table of contents, the first of which is numbered because that one I have started, the rest of which are not because I haven't started those yet. I left a couple of pages blank for the table of contents. I have experiment 1, massive volume determination. This is actually from a 110 lab notebook, but the same things apply. It says to see the lab manual, and then that the year that lab manual was for and the pages are given. The reason for that is when you work in industry, we typically have set procedures that we use. And so we don't reference them in our lab notebook because chances are we're doing the exact same thing every day. So we don't need to record that in the lab notebook. But we need to have a record of what that procedure was. And so that is documented elsewhere, and a document number or date is given to it so that somebody can go back and look at what that document looked like at the time and see exactly what you did. That would allow them or you to perform this experiment again and hopefully get similar results. That's the objective. So your objective needs to be in your name. I want to see pictures or descriptions of the materials that are required. I show this image only because if you're going to put something into your lab notebook, be it glued in, taped in, whatever, and I don't care what it is, if it's a printout of the lab manual, if it's a picture that you're putting in there, I don't care. You need to sign across that in such a way that if that image or piece of paper is removed, someone will know that something was there that is no longer there. Okay, so if you've taped this in, this actually should go over the tape. When I put this in, this was glued in. So obviously the paper will look weird if we take that out, but then part of my signature will be there and part of it won't. So that's an indicator that we've done that. And then of course there's a date for that as well. There's a bunch of other stuff here. The only other part that's required is the data tables. You are usually given data tables, so you are not responsible for setting them up however these are set up. That's something that I did on my own because we weren't provided with that, so I did that myself. I made sure that there was a space available for me to record all of the data that I needed to collect, because if there was a space left and there was nothing written in it, then I wasn't done. Okay, so that was my thing. Data tables you will be given. These are expected to be filled out at some point, and we will talk about that in a little bit. The only other thing I want to talk about, so here, there's a line through initial and date. So cross out the mistake that I made there. You'll see an X through this space, initial and date. We don't leave blank spaces. And the table of contents is a little bit different because we know that that's going to be open and that's not a big deal. But when we start a lab notebook, we continue to use it just one right after the other. We don't leave blank space because we aren't going to going back and adding things later. We don't, write stuff down on little sheets of paper and then go back and make it pretty. That's not what we do. Your lab notebook is a legal document that has to be written at the time the observations are made. So it doesn't matter if it's pretty. It matters that it's there when you do it. Okay. And I will say again, if you don't write it down as you do it, chances are you're not going to remember exactly what it was. And so then you're either going to have to take the measurement again, or you're going to guess as to what that number was. And that's a bad idea. All right. I will tell you that my physical students, the ones who are physically in the lab with me, if they don't take their lab notebook to the bench when they're making a measurement for a weight, and they're walking back trying to think through in their head what that weight was, I will walk behind them and I will either spit out numbers, or I'll do my times tables, or I'll just start singing, because they need to understand that they need to build that habit to take that lab notebook with them wherever they go. And part of that also comes from, let's just say that we're waiting for something to happen and it's going to be 20 minutes. And so we go to do something else and we turn around and we see that it's doing something that we totally didn't expect. That happens. Suddenly it's turned purple, or it's overflowing, or somebody knocked it over. All of those things are observations that I need to make, and I don't have my lab notebook. I can't make them. Okay. And the other thing is, if I had left my lab notebook there, then it could have spilled on my lab notebook. So we want to take our lab notebook with us. And you'll see that there's a thing for a signature and date for the analyst and a countersign. You do not need the countersign. That is only if you're physically working in a lab, and that's to acknowledge that you did this work on that date. So two people's signatures and dates. They have to be different signatures, have to be the same date. Okay. Now it's acceptable within short amounts of time to not have them be the same. I mean, realistically, we say if it's longer than a week, that's a problem. Was this something that we had to do at work? Absolutely. So what we would do is when we were done with our lab notebook for the day, we had someone who was assigned to sign off on that lab notebook every day. And so we would hand it to them, or we would leave it on their desk, and then we would go and collect it from them the next day. That was the procedure that we had. And that's why we had the little schedule to tell us who was supposed to sign what on what day. So we had that available to us. Now you'll see that this is X'd out again once I'm done with the data collection to indicate that the rest of that page is not necessary. Now, could I start the next experiment there? Yeah, of course I could. But in my head, they're two different things, so they're two different pages. Okay, so that's lab notebook stuff in general. So I'm going to get rid of this part now. And let's talk specifically about what needs to go in your lab notebook. Now, the document that I'm looking at here is the one that you were given. It's called the lab data. Okay, so you'll see that the % transmittance are filled in for this. So you're in the pre-lab, it says that you're supposed to write these tables, and then you're supposed to record your data. Now, the only data that you actually have to record for this experiment in the laboratory is the percent trace minutes. So that's what's filled in here, okay? So that's why this is here. So when you put this table in your notebook, you need to put that data into that table. There's one other thing that it says that you need to do as a pre-lab activity. So any pre-lab activities need to be in your lab notebook, okay? It says there's one other thing that you're supposed to do as part of the pre-lab. It says using the information in the procedure, and M1V1 equals M2V2, calculate the molarity of the dilute Fe3 plus solution prepared and recorded in the data table below. Okay, right. So let me find my other documents. And this is my lab notebook. And if I scroll down to where we start talking about the procedure itself, the first thing it says is using a volumetric pipette, prepare a dilute solution of Fe3 plus by adding 10 milliliters of 0.00200 molar FeNO3 to a 25 milliliter volumetric flask. Once it's added, carefully dilute the sample with distilled water to the calibration mark. So since it's a 25 ml flask, that line is going to be exactly 25 mils. These are very precise little things that we work with. Okay, so that's the information that I need to determine how this was carried out. Now, M1V1 equals M2V2. M stands for molarity, V stands for volume. And what this means is that I take a certain volume of a certain molarity, then I add that to something, and I dilute it with water to a different volume. So I can use this equation to solve for the new molarity. So I'm going to be solving for M2. So I'm going to take M2 is equal to M1V1 over V2. Okay. When we look in our lab manual, the M1 that we're given is 0.00200 molar. And I see that right here. It's that number right there. Okay, so that's my M1. The volume of that I use, my V1, is equal to 10 milliliters. And the V2 is the total volume. So not how much water I added, but the total volume of that solution. Since it's a 25 ml volumetric flask, that's going to be 25 milliliters. Okay, so now I can plug that data into my calculation. I have my 0.00200 molar. I multiply that by the 10 milliliters that I start with, and I divide that by the 25 milliliters that it's going to be at the end. The milliliters cancel. I'm left with an answer that has a unit of molarity. All of my calculations include units, so you'll get used to that. And I can calculate that answer. Now that answer, I'm going to call number 3. And that's because I calculated it for 3 up here. So I'm going to call that number 3. We're going to use that later on. But that's the only part that needs to go in my lab notebook, is that part right there. Now, it tells you to plug that in right here. So that number is actually supposed to go there. Notice that there is a molarity given for the iron, the thiocyanate, and the HNO3 that you're going to be using to make your dilutions, or to make your solutions in the second part. So we want to know what the molarity of that Fe solution is when we take that volume, okay? So that's where that comes in. Now, are you required to include all of the rest of these calculated things? No, not at all, okay? You are not required to include any of that, okay? But for me, I like to fill it out in here. So in my lab notebook, the tables that I made, I like to fill out the tables in the lab notebook, because then that's my rough draft. And then my final draft is the paperwork that I'm going to turn in. So when we talk about that, that gets us started into the data. Now I'm going to pause here and say, okay, that's it for the lab notebook, because that's everything that has to happen in the lab notebook. I'm going to stop here, start a new recording, and then we'll talk about what else needs to get done with that data, okay? How we take it all together and get it ready to be able to do the rest of the stuff that we're going to do. So I'm going to stop sharing, and I'm going to stop the recording, and I will see you.